Have you ever struggled with tree traversals? This video will cover everything in one shot. Hi everyone, welcome back to another video. My name is Gurmeet Singh and today in this video we are going to do tree traversals in one shot. In this video basically we are going to cover 5 essential tree traversals: InOrder Traversal, PreOrder Traversal, PostOrder Traversal. For these 3 we will discuss the recursion stack implementation and dry run. Then we will jump to the level order traversal. We will discuss its queue implementation and minor tricks to print the levels line by line. And at the last, I will be going to cover one of the most doubted one, Morris Traversal, that at initial stage I also found it difficult to understand. But don't worry, because in this video I have come up with a very amazing explanation with which you will never forget it. So this video will be really exciting. Are you also excited for this video? If you are also excited, please like, share and subscribe to my channel for keep motivating me for bringing more such content. So let's get started. Let's start with the first traversal, that is PreOrder Traversal. But before starting the PreOrder Traversal, let's understand something. For any node, there can be the 3 points it can be touched. So if I say you this is a tree, and if I traverse, let's say like this. So you can see at 10, there can be the 3 points, this and this. So they are the 3 points. This is called pre, that is before starting the traversal, that is pre. And after completing the traversal at 10, this is post, and in between is in. So these are the 3 points, pre, in and post. So this you need to understand because we are going to use this thing in the traversal. Now let's jump to the PreOrder Traversal. What PreOrder Traversal says, as the name suggests, pre means first cover the node, then go to left, then go to right. In simple words I can say, for this tree, and if you talk about 10 will say first print me, then complete the left, then complete the right. This is a simple thing that PreOrder Traversal says. So this is like node, then go to left, then go to right. So let's do the PreOrder Traversal now. Then we will jump to the coding part, that how recursion stack implementation will be done. Let's do it now. So if I say you this is a 10, so what PreOrder Traversal says, that first print me, okay. Now we will say 10 will say okay, if I have done, now go to the left. So we will go to the left. Now we will come to 20. Same story happens with 20 as well. Now 20 will say okay, print me. 20 will say okay, now I am done, now go to my left. 20 will also say now go to my left, then go after completing the left, go to my right. So we'll say okay, we will go to left, that is 40. So we will print the 40. Then 40 will say go to my left, that is null. 40 will say go to my right, that is null. Then we will come back to 20 because 20's left part is covered. We will come back to 20. 20 will say now go to my right. So after going to my right, this is again null. So we will come back to 20. Now 20 will say that I am completed. I have been printed myself. I have completed my left. I have completed my right. Now come back to 10. 10 will say that my left is completed. Right? 10 will say I have printed myself. I have completed my left. Now 10 will say now time to jump to right. So when we jump to right, we will come to 30. Now same story happens with 30 as well. 30 will say let's print me. So we'll print the 30. Then 30 will say okay, I have been printed, now go to left. So we'll go to left. So again 50 will say print me, go to left, null, go to right, null. We will come back to 30. 30 will say my left is completed, now go to right. Now we will go to right, that is 60. 60 will again say left, right, and will come back to 10 somehow, right? So this is the PreOrder Traversal. So it was very simple to understand what it says. First print myself, go to my left, after completing the left, then go to my right. Now time to jump to its recursion stack implementation with code. So let's understand the recursion stack implementation. So we have understood that what is PreOrder Traversal. Now we need to understand that how we will do it in coding part, right? So there is a simple recursive function that represents the PreOrder Traversal. It says that first print myself, then go to my left, then go to the right. This is the recursion says. The recursion says that after completing the left, it will automatically jump to the next statement, right? So let's understand it. Let's say this is a tree and this is a recursion stack. For example, if the main function calls the root node function of 10, that is PreOrder of 10, let's say. So what will happen? This function of 10 will be pushed into the recursion stack, like, because we need to operate on this, right? Now what function of 10 will say? When we call the function of 10, it will say okay, we will call this function of 10. First print me. So let's print it. Then we will say call the left. So that is 10 left is 20. So we'll say push it into the stack and apply this function. So we will again say preorder will say I have been called. Now nodes data is 20. So we'll print it. Now after printing the 20 will again say go to my left. So we'll call the left. We will push the function of 40 in the stack. Now 40 will say print me. We will print it. Then 40 will say okay, my left is done. I have been printed. Let's go to the left. So we'll go to the left. That is null. We will come back. 40's right is null because 40 will say print me. Then it will go to left. That is null. Right is also null. We will come back to 40. Now 40 will say that I have been printed as well. My left is also called. My right is also called because I have been completely done. Now time to remove me from the stack. Now stack only keeps the thing which we need to operate upon. But 40 is already completed. 40's that is also completed. 40's left is also done. 40's right is also done. So we will pop out 40 from the stack. Now 20 will say where I was. 20 will say that I have been printed also. My left is also called. That is already done. Now time to call my right. So when we call the right, we will say it is null. So we'll again return back. Now 20 will say that I have been printed as well. My left is also done. My right is also done. Now time to pop it out from the stack. Now after calling the 20, we will come back to 10. Now 10 will say where I was. 10 will say that I have been printed and my left is also done. Now time to go to my right. So when we go to the right, we will call the function of 30. Now function of 30 we will operate upon. It will say print me, then go to my left. So we'll again go to left. It will call the function of 50. So we'll again push it into the stack. We will print the 50 as usual. 50 will say call my left, nothing. Call my right, nothing. 50 is done. Pop it out from the stack. Since 50 is done, we will come back to 30. 30 will say where I was. I have been printed as well. My left is also completed. Now time to go to my right. Now when we go to right, we will call the function of 60. Now 60 will say I have been printed right. I will go to left. This is nothing. This is also nothing. We will come back to 30. Now 60 will be popped out. 30 also done. 30 will be popped out. 10 is also done. We will come back to 10. 10 is also popped out. So the final control comes to the main function, and this is the pre-order traversal of the binary tree. So it's pretty simple that whenever we want to call the pre-order traversal, we will first print the node. We will complete the left. We will complete the right. Same story happens for every node, right? So this was a pre-order traversal. Now time to jump to the coding part of pre-order traversal. So let's jump to that. Let's code the pre-order traversal. So we will call it with the root node, tree node star root, and we will also pass a array where we will store our answer instead of printing. So we will say, okay, first what we will do, push into the answer roots val, that is whatever we want to print in the pre. Then we will call the left, roots left answer. Then we will call the right answer. And we will say if any time null comes in, we will just return from there as we were doing. Whenever we want to go to left and there is null, we will return from there only. So now time to call the function. We will say pre-order of root comma answer. So we will return the answer here and we will create the variable here as well. Vector int answer. Let's try to compile run the code and check whether it's working fine. Yes, let's submit the code. So yes, it's totally working fine. Now time to jump to the time and space complexity of pre-order traversal. Now what happens in pre-order traversal, that what we were doing, we were going to every node, and you can see we are going to every node 3 times only. Before starting, after completing the left, then coming back to right. So there are 3 points where we are covering the node. So we can see we have, let's say, n nodes. Then we will cover the node 3n times. So approximately we can consider n only. So time complexity is big O of n. But the space complexity is big O of h. Why? Because this is a recursion stack space that we are taking. the answer variable will not be considered as space because it should be stored obviously, but the space considered is extra space, that is recursion stack space that we are taking. And that we are taking is we are always going to maximum height. Till then we will store the recursion stack, otherwise we will pop out and then store. So you can consider whatever is the maximum height, that is the recursion stack space, and that is the space complexity. So this was about pre-order traversal. Now time to jump to the next traversal, in-order traversal. So let's understand the in-order traversal. Now what in-order traversal says, as we've understood the pre-order traversal, it was saying first print me, then go to left, then go to right. In-order traversal says that first go to left, then come to me and print me, then go to right. Let's understand it. So for example, let's say this is a tree. What will happen? We will start the traversal again from here. We will come to 10. Now we don't need to print. We will just say go to left, don't print me. Now 20 will say go to left, don't print me. Now 40 will say go to left, don't print me. Now after completing the left, 40 will say my left is completed. Now time to print me. So 40 will print itself. Now 40 will say let's go to right. Okay. Now right, it's completed. Now we come to 20. 20 will say my left is completed. Now time to print me. So 20 will be printed. Now 20 will say that go to my right. Again right is null. We will come back to 10. 10 will say that my left is completed. Now time to print me. Okay. 10 will say go to 30. Don't print me, just go to left. 30 will say go to 50. Left. 50 will say go to left. Now after completing the left, we come to 50. 50 will say my left is completed. Now time to print me. Now we come to right. Again after coming to right, we will go back. We will go back to 30. 30 will say my left is completed. Now time to print me. 30 will say my left is completed. Now go to right. So we come to 60. 60 will again say let's go to left. Left is completed. Let's print me. Then after going to right, we will come back. So this is the in-order traversal of this binary tree. So it's pretty simple. It says that first complete the left, then print me, then go to right. So that's why it's in. It says after completing the left, then print me only, not before. Before was a pre-order traversal. So now time to jump to the recursion stack implementation of in-order traversal. We will discuss it very quickly because we understood the pre-order traversal and we have built our base that how the recursion stack implementation goes on, right? So let's jump to the recursion stack implementation. So this is again the simple recursive function that I've written of the in-order traversal. It says that first go to left, after completing the left, print the data, then go to right. So this is the in-order traversal, right? We have understood. Now this is a binary tree and this is the recursion stack that we're going to use, and here we will print the answer. So let's start. Let's say main function calls the in-order traversal, that is function of 10. So what will happen? Function of 10 will be pushed into the stack, right? Now time to call this function of 10. So what will happen? We will say 10 will say that go to my left. Don't print me now, go to my left. So we'll go to the left and we'll push the function of 20 in the stack. Now when we come to 20, 20 will again operate on same function. 20 will say go to my left. So we'll say okay, function of 40. Now 40 will say, again say 40 will say just go to my left. So now 40's left is null. We will come back. 40 will say my left is completed. Now print me. So we will print the 40 and then we will go to 40's right according to this function. We will come to 40's right, and after completing the right, we will go to the 20. So since 40 is completed, we will pop it out from the stack as usual, and then we will say 20 will say that my left is completed. Now print me. So 20 will be printed. So 20 will say okay, I have been printed. Now according to this function, go to my right. This is null, come back. We come back to 10. So this is pop out from the stack. Now 10 will say that my left is completed. Now time to print me as well. So we'll print that 10, and then we will say 10 will say that I have been printed. Now go to my right. So we'll go to the 10's right and we will call the function of 30 now. Now function of 30 will say now call the same function for me. 30 will say okay, call my left. Let's call its left. So we will call the function of 50. Now 50 will say again operate on same function. Because 50's left is null, we will come back to 50. We will print the 50 and then we will say go to my right. We will go to the right. Since right is also completed, 50 will be popped out from the stack. Now we come back to 30. Now 30 will say, my left is completed, time to print me as well. So now after printing the 30, we will say we have left is completed, 30 is also printed. Now time to go to its right. So we'll call the function of 𝗙𝗊. 𝗙𝗊 will say go to my left, left is completed. So let's print me as well. We will come back to 𝗙𝗊. 𝗙𝗊 will say I have been completed, pop it out from the stack. 30 will say I have been also completed, pop it out from the stack. 10 will say I have been also completed, pop it out from the stack. So this is how only main function takes the control and print the final answer. So this is the InOrder Traversal of the binary tree. Now time to jump to the code of InOrder Traversal. Let's do the code of InOrder Traversal. So here we call the function InOrder, where we will pass the root and we will pass the array as well, answer. And what InOrder Traversal says, go to my left, then after completing the left, push the answer, roots data, that is. Then we will say, go to my right, as usual. And whenever null comes in, just return. If root is null, just return. Let's call it vector int answer. We will call the InOrder of root comma answer and we will return the answer. Let's try to compile run the code and check whether it's working fine. Let's submit the code. So yes, it's totally working fine. Time to jump to the time complexity and space complexity of InOrder Traversal. The time complexity, space complexity is similar to preorder only. It is like we are always going to same element 3 times, so 3 into n, and we can neglect the 3, we can consider big O of n. And the space complexity is again h, that is the maximum height of the tree, because that much recursion stack space will be taken. So this is the time complexity and space complexity of InOrder Traversal. Let's jump to the next traversal, PostOrder Traversal. So we discussed PreOrder Traversal, InOrder Traversal. Now we are jumping to PostOrder Traversal. Now what PostOrder Traversal says, that go to the left, complete the left, then complete the right, then print the value of the node. So let's understand with the tree. So if I go to this tree, so we'll say we will come to 10. 10 will say go to my left rather than printing me now. So 10 will say go to 20. 20 will say go to left. 40 will again say go to left. 40 will say complete the left, complete the right, then go to 40 and print it. We will come to 20. 20 will say that left is completed, go to the right, right is also completed, print the 20. Now 20 will say go to 10. 10 will say go to the right, go to 30. 30 will say go to left. 50 will say go to left, left completed, right completed, then print 50. We come to 30. 30 will say left is completed, go to right. We will go to right 60. 60 is left completed, 60 is right completed, then 60 is printed. We will go to 30. Now 30 is printed because 30 is left and right is completed. We go back to 10. 10 will say my left is also completed, my right is also completed. Now let's print me. So this is the PostOrder Traversal of this binary tree. Now let's jump to the recursion stack implementation of PostOrder Traversal. We will again cover it very quickly because we have already covered InOrder Traversal and PreOrder Traversal now. So this is a binary tree and this is a recursive function of PostOrder Traversal, very similar that PostOrder of left, PostOrder of right, and then we go to the data. So this is a recursion stack and this is where we store the answer. So let's start now. Now main function will call the PostOrder of root, that is 10. So let's call the 10 and let's push it into the stack. Now 10 will say, okay, let's go to my left. We will go to left, that is 20. So push it into the stack. Now 20 will say, go to my left. Go to 40. 40 will again say, go to my left. We will say null, go to my right, null. Now 40 will say left is also called, right is also called. Now print me. So we'll print the 40 and then we come to 20. So we will pop out 40 from the stack because it is done. Now 20 will say my left is completed, let's go to right. So we'll go to right, that is null. Now we come back to 20. So 20 will say that since 20's left is done, right is also done, let's print it. And since it is completed, pop it out from the stack. Now we go to the 10. 10 will say since left is completed, now go to right. So we'll go to right. Now 30 will be pushed into the stack. 30 will say let's go to left. we will go to left 50, we will call the function of 50, 50 will say go to left, null, null, now 50 will say print me and pop it out from the stack. Now 30 will say left is completed, go to the right, function of 60, now we will go to the left of 60, right of 60, come back to 60 and print it. Now we pop it out from the stack. 30 will say left is completed, right is also completed, pop it out and write the 30 here. Then we will come back to 10, 10 will say left is completed, right is also completed, write the 10 and pop it also out from the stack, and finally we got the post order traversal of the binary tree here. So this is a post order traversal. Now time to jump to the code of post order traversal. Let's call the function post order with the tree node star root, and we will pass the array answer for storing the answer. And what post order traversal says, post order traversal says go to the left, then go to the right, then push it into the answer, root, val, and we will say if it is null, return from there only, and then we will say that create the answer variable and post order of root comma answer and return the answer. Now let's try to compile run the code and check whether it's working fine. So let's submit the code again. I think it will work fine. So let's jump to the time and space complexity of post order traversal. So as usual, time complex is again big of n because we are traversing each node 3 times, and space complex is big of h because we are covering the maximum height of the tree. Now let's jump to the next traversal, that is level order traversal. Now as the name suggests, level order traversal is just we are covering level by level. But so let me tell you one thing here. So we have two types of traversal, DFS and BFS. DFS is depth first search and BFS is breadth first search. So we have done the PreOrder Traversal, InOrder Traversal, PostOrder Traversal. These 3 traversal are depth first search. Why? Because we are going to depth only, left, 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 then coming back, then go to right. So we are always trying to go to depth, as much depth as possible. But level order traversal is BFS, that is breadth first search. We want to cover first level, then second level breadth wise, right? So this is a level order traversal. Now let's understand the level order traversal. It's pretty simple. This is the first level, this is the second level, this is the third level. So we'll say that this is 10, next level is 20, 30, we will print 20, 30, next level is 40, 50, 60, we will print 40, 50, 60. So this is a level order traversal of the binary tree. Let's understand its queue implementation. So basically there are two things, BFS and DFS. BFS is implemented by queue, DFS is implemented by stack, because stack always maintain the depth, as much depth we can go. But for breadth first search, since we want to cover levels by level, so there we use a queue. So now let's understand its queue implementation. We will better be able to understand how BFS happens with the queue. So this is the queue and this is the answer array, and this is a binary tree on which we are going to perform the level order traversal. So let's start. So we'll say this is a 10. So first time, let's push the 10 into the queue. Now we will say pop 10 from the stack. Now main function will push the 10 into the queue and call it. So we'll pop the 10 from the stack and we will push it into the answer. After popping out, push into the answer. Now we will say okay, 10's left is 20, 10's right is 30. Push both of them into the queue. So we'll push them 20 and 30. Now 20. Now again we come to 20 because 10 is always popped out. Now we come to 20. 20 will say that pop me out from the queue. So we'll pop it out and push it into the answer. And 20 will say, where is my left? 40. Where is my right? Null. So let's add 40 only because right doesn't exist, right? Now we come to 30. So you can see why we are going level by level. That after 10 we have pushed both of them. So after 20 I am not going to down. Rather I am going to next node in the level only. This is because of queue. Queue maintains level by level. Left, right, then left, right, left, right. So all these levels it will maintain. So now we come to 30. 30 will say again, pop me from the queue and push me into the answer. 30 will say, what is my left? 50. What is my right? 60. Push it into the queue. Now we come to 40. 40 will say pop me out. We will push it into the answer. 40 will say my left null, right null, don't add it. Now we come to 50. 50 will be popped out. Push it into the answer. We will push it. And 50 will say what is my left? Null. What is my right? Null. So nothing, we will add it. So now we come to 60. 60 will again say pop me out. Push it into the answer. Left, right, null, nothing. Q now becomes empty, and this is the answer of level or traversal. 10, 20, 30, 40, 50, 60. So you can see 10, 20, 30, 40, 50, 60. This is how we maintain the level order traversal. Now here comes the twist. If anyone asks me, print all the levels line by line, then how will I do that? So there can be many approaches, but let me tell you one approach that I mostly use many of the times. So this approach is that maintain the queue size at every level. Let's say initially queue size was 1, right? So we maintain it 1. So we say when the queue size is completed, maintain it in a variable, because queue size will increase, decrease. We will add the variable, pop the variable, add them, pop them. So queue size will again become bigger, smaller, right? But let's maintain it in a variable only. Before that, we will say queue size is equals to 1 initially. So we will say when this one element is popped out and pushed it into the answer, then add the slash in, right? So again, let's say 20, 30 is pushed into the answer. So we will say queue size was 2. So when these two elements are pushed into the answer, then we will again add the handle, right? So this similar thing that we can do. So let's jump to the coding part of level order traversal now. Now what we will say, in the level order traversal, we can see in the output array, we need to print the levels line by line. So here we will understand the use case of queue size. So what we will do, we will create a 2D array of answer here, because we need to print the array line by line. Now we will maintain a queue since we need to do the BFS here, that is level wise. Now what will happen, we will maintain the queue of tree node star, that is pointer, instead of integer. Why? This is because we need to go to left, right, and this can only happen using pointers only. So that's why we need to maintain the address, that is tree node star, right? So now initially we will push the root into the queue, and we will say until the queue does not becomes empty, do this, and at the last, when this is completed, return the answer. Now what will happen, at every level we will maintain the queue size, as we discussed that we need to maintain the queue size since we need to cover the each level, then print the handle, right? Or you can say we need to push it into the separate vector, separate array. So we will return, we will say queue size until the queue size does not become 0, that is one level does not gets completed. We will take out the node from the front, pop it out from the queue, and we will say if left exists, then push it into the queue, and if right exists, push it also into the queue. And we will say that at every level we need to push the elements. So this is a sub answer that we can create, or you can say sub level, anything. Sub answer dot push back nodes value, and at every point we need to push the sub answer. After completing every level, we will push it into the 2D vector. When D vector is pushed into the 2D vector, so we will return. One more thing, since the nodes can be 0 as well, in the constraints it has been given that number of nodes can be 0 as well. So we need to do the handling here, that if root is null, then return from there only. Let's try to compile it in the code and check whether it's working fine. Yes, let's submit the code. So yes, it's totally working fine. Now let's jump to the time and space complexity of level order traversal. Time complexity is big of n. This is because we are traversing all the elements one by one. That's why we are traversing n elements, so it's big of n. Space complexity is big of n. This is because we need to maintain the queue, and queue for adding the elements, popping out the elements. That's why it is big of n. Answer 2D vector will not be considered as extra space. So this is about time and space complexity. Now time to jump to the most important traversal, that is Morris Traversal. With Morris Traversal, we can do multiple traversal, InOrder Traversal, PreOrder Traversal, but PostOrder Traversal is not possible with Morris Traversal. We will discuss it later, but let's understand Morris Traversal now. Morris Traversal, do the traversal in big of one space. Initially in InOrder, pre-order, post-order, we were using extra space, that is stack space, for doing the traversals. But Morris Traversal says we can do it in big of one space as well. So how can we do it? Let's understand. Now, why we were using the stack? We were using the stack because after completing the left, we want to jump back to right. This is a part only of stack, that complete the left, then after completing the left, print the variable like that, and then go to the right. So the main aim of stack was to go from left to right. So this was the main aim of stack. Now, how can we do it in big of one then? We can use the threads. Now, Morris Traversal uses a concept of threaded binary tree. How it does that? It will say that whatever is the last element here, last element at the 10's left is 50. Because we want that after completing the 50, we can jump back to 10, so that 10 will say my left is completed, now time to go to the right. So we will say 50's right will be pointed to 10. So that after this part is completed, we can jump back to 10, and 10 will say let's go to right. Similarly, if we say 20, 20's left is 40. So 40 will say if the left is completed, we need to go to 20. So here we again use a thread. Similarly, here we use a thread. Let's understand now. So initially what we will do, we will create the thread of every left part last node, right? So let's create the threads here. So left part here is 50, last node, then 40 is the left part, go to 20. Because it's null, we can't create, obviously, right? So now for 60, for 30 we have left part as 60. So we will say let's create the thread here. So using this thread, we will do the traversal now. Let's do the pre-order traversal first. InOrder Traversal we will understand. So let's do the traversal. So we will print the 10, then we go to 20, then we go to 40, then 40 will say go to left, that is null. 40's right is not null now because it is pointed to 20. So 40's right will go to 20. Now 20 will say there is a thread from 40 to 20. That's why, because left is completed, now we will jump to right. So we will come to 50. Now 50 will say null. Now 50 will say this right part is the thread now. So we will go to 10. Now 10 will say, so 10 will say there is a thread from 50 to 10. That's why left part is completed. Since thread is there, that's why left part is completed. We will jump to the right. So we'll come to 30. 30 will say let's go to left. 60 will say there is a thread here. So we will come to 30 back. Now 30 will say I have been coming up from thread only. So that's why it was left. Now go to right, it's null. We will go back, and this is the pre-order traversal using Morris Traversal. We will better understand this traversal using its implementation. So let's do the dry run of this. So let's understand its dry run now. So what happens at every node, what we want, go to its left part. So we'll go to its left and go to its extreme right and point it to the 10. So we will say that when we come to 10, we will say go to its left, that is 20, and we will go to its extreme right, that is 50. So we will say point it to the 10. Now we will print the 10 in the pre-order traversal, and we will go to its extreme right and we will point it to the 10. So let's point it to the 10 now. Now we come to 20. Since we are doing the pre-order traversal, we will come to 20 and we will go to 20 and we will say again. Now 20's left is 40. 40's extreme right is null. So we will say that 40 is only the last node of the left part. So let's create the thread from here and take the 20 in the pre-order traversal. Now we come to the 40. Now 40 will say, okay, print me now. Okay, now your left does not exist. So we will say like 40 will say, okay, my right exists. There is a thread. Now 40 don't know that it's a thread, but 40 will say, let's go to my right. So we will go to the 20. Now when we come back to 20, 20 will say, according to the coding part, 20 will again say, go to my left, go to my extreme right and point it to the 20, right? So 20 will again do this, but 20 will find it that there is already a thread there. That means left part is completed. If there was a thread, that means left part is completed. So we will say that let's remove this thread because left part is completed. So we will remove this thread now. So we will remove this thread, and now 20 will say since thread left part is completed, now time to jump to the right. So let's jump to the right. We come to 50, and according to the PreOrder Traversal we will take 50. Now 50 will say that my left is null, but my right is something. Let's go to 10. There is a right, let's go to 10. 10 will retry the same process. 10 will say go to my left, go to my extreme right, point it to the 10. But it will say it is already done. That means its left part is already done. So we will say remove this and jump to right now. This thread is only helping us to go back to 10, and this thread is only helping us to analyze that left part is completed. So now we will go to the right part. So when we go to the right part, we come to 30. We will take the 30 and go to its left, go to its extreme right, that is 60 only. We will create the thread and we will come to 60. Now 60 will be taken. 60 will say my left does not exist, but my right exists. So we will go to right. Now we come to 30. Now 30 will say that let's retry the same process. Go to my left, go to my extreme right, then point me back. So when we point it back, 30 will say I have already been threaded. So we can remove this thread and let's go to its right. Since right nothing exists, so we will finish here only. And this is the PreOrder Traversal using Morris Traversal. This is the main intuition that left part is completed, then we'll jump to right. And using the thread we are doing that, right? So now let's jump to the coding part of this. We will better understand there also. So let's jump to the coding part. So now what we will do, we will maintain an answer vector, and now we will maintain a variable pre-node star current is equals to root, and we will say while current is not equal to null. And what will happen that if currents left exists, there is one thing, else if current right exists, there is other thing. Now when left exists, what we will do, as we discussed, we will go to its left, then go to its extreme right. So we'll say pre-node star temp is equal to current left, and while temp right is not equal to null, go till that point. And after that, when we go to that point, we will say point its right to the root node. Temp's right, not root node, the current node, you can say. Temp's right is equal to current. Now you will say one thing, it can also happen. We come back to same node, same code retries, same it will make the thread, so it will go in TLE obviously. So how we will handle it? We will say that with this condition, add one more thing. Temp's right is not equal to current. Why? Because maybe it is already threaded. So we will say if it is already threaded, we will add this condition here. Temp's right if equal to current, that means already threaded. So this will break here only because of this condition. So now if it is already threaded, we will say make it right equal to null. And also move from this node to right, because this node's left part is completed, but we need to jump to the right part. So now what will happen, if this is condition, fine, but if we need to make the thread, then we will say make the right is equal to current, also current is equal to current left. Why? Because we need to jump to the left part, right? Because current part is done before that, what we will do, we will push it into the answer, that is current val. And now there is other case, if left does not exist, there is null on the left, then we will jump to the right. If the left does not exist, then the current node only will be added in the answer as well. Why? Because left does not exist, so current node will come in PreOrder Traversal, and we will jump to right, and we will say current is equal to current's right, and at the last we will return the answer. So I hope you get it, like we are doing two things only, left and right, and in the left we are trying to check thread is already there. If thread is already there, then remove the thread, take the right part, and if the thread is not there, create the thread, go to the left part. What will happen? So there is one thing, if left does not exist, right does not exist, and we have current node, so there is no condition here, so it will go in infinite loop, that is CLE. So how we will handle this? We will say let's go to the right part. Right part can be null and right part can be something. Let's go to the right part only. So now when we compile the code, it is working fine. So let's submit the code as well. So it's totally working fine. Now let's do the InOrder Traversal using the Morris Traversal as well. So now what we will do, we will copy this complete code and paste in InOrder Traversal. And let's see what we need to change. So let's reset this InOrder Traversal part and let's write it here. And now what we will say, there is 2-3 things that we need to change. If the thread is already there, then we need to jump to the right. But before jumping to the right, can we store it in answer? Yes, because InOrder Traversal says before going to right, push it. So we will say push it here. But while going to left, don't push it. Remove it from here. And we are going to right, this is also fine. Let's compile and run this code and check whether it's working fine. Yes, it is also working fine. Let's submit it as well. Yes, so this is also totally working fine. Now let's jump to the time complexity, space complexity. Then we will discuss how that PostOrder Traversal is not possible using Morris Traversal. So the time complexity is big O of 2n. Why? Because for every node, we are just trying to go it for 2 times only. Why? Because when we come to the same node after creating the thread, so we again do the same thing. So we do this only 1 time to check whether the thread is there or not. So that's why it's 2n. Space complexity is obviously big O of 1. We have reduced the space, right? So now let's understand that why PostOrder Traversal can't be done using Morris Traversal. So what was happening, that we were creating the thread like this. So let's see. This is one thread using that instead of null we are just pointing, we are pointing here and we are also pointing here. So what was happening, that we go to 10, 20, 40, then we come to 50, then we directly jump to 10. You can see we are not going to 20, but in PostOrder Traversal, while going from 50 we need to go to 20, then go to 10, but thread is from here to here. That's why PostOrder Traversal cannot be done using Morris Traversal. So this was a reason for PostOrder Traversal not possible. So I hope you like this video. This video took really good amount of effort than I thought of. So I hope you like this video. If you like the video, please like, share and subscribe to the channel. Also do share with your friends because it will motivate me for bringing more such content. Also do comment out if you want more such videos. I will be happy to create it. Thank you and have a nice day.